because I want to take a very critical look at what's happening in our environment. I went ahead while you guys were off camera, I removed the configuration on Cat 1 and I went in and removed the configuration on R1 so it's not generating BPDUs. Right now what I want to look at is I want to look at another notion, and that's going to be this idea of how we're going to be first protecting ourselves. And the first option was BPDU guard, the second option was BPDU filter. Now when we do BPDU guard or BPDU filter, we can do it globally based on how we've got our port fast configurations configured, or I can do it individually under the interface. I think possibly I need to look at that first before we cut over to doing anything else. But when we access our system and we go in and take a look at, say for instance, interface, let's take a look at the ones that are running our bridging. So show spanning tree, VLAN 1. Now let's pick an interface here. All right, the interface I'm going to play with is not going to be FAO1. What we'll do is we'll configure it for 19. All right, now when it comes time to look at 19, show run interface FAO19, show run interface or show spanning tree, VLAN 1, interface FAO19. All right, so I can even come in here and say detail. Now, what we see here is some information that I want to make certain that we go through. So on port 21, which is actually port 19, and this should make perfect sense because what we have to recognize is this is a Catalyst 3560, which has 24 fast Ethernet ports, and it has 2 gigabit Ethernet ports. So what we're doing here is that our calculation is always going to be +2. So if I'm on the 19th port, it's going to be +2, so it's going to be 19, 20, 21. That's going to be the designator that the system is going to use to recognize my port because it puts the gigabit interfaces first. Now looking at this, we see some information. What I want to look at right now is going to be the idea of this concept with regard to how we're going to be communicating with the distant end. So right now I'm on Cat 1. And Cat 1 is the root bridge. At least it should be. 4097, yes I think it is, designated path cost. Here's what I want to talk about right now. I want to talk about the designated path cost. The designated path cost is the value that's being reported to me by my neighbor, which is its cost to reach the bridge, the route. Now since this is the route, then that value is going to be 0. So to illustrate that point, I want to go over to one of our other devices. So let's go over to Cat 2 and take a look at the output here. So first of all, we'll pick port 20 GIO1. So here we'll say show spanning tree, VLAN 1, interface, GIO1 detail. And let's take a look and see what we've got here. Now notice we have this value that I'm talking about, designated path cost. Still 1, I mean 0, because it is the root bridge. Now when we go in, right now the way we've got our current topology set up, we've got Cat 1, we've got it is the root, and then we have the radial connections down to Cat 2, to Cat 4, and to Cat 3. So what I'm going to do is I'm going to go over here to Cat 4, and I'm going to make Cat 4 the root bridge. Now in doing so, first of all, I think I need to remove any config I have here. So show, run, section, priority. No, it's a switch. Include priority. 4096, nope, I can actually come down here and just pick VLAN 1. So config T, spanning tree, for VLAN 1, priority 0. The question is William's asking, does spanning tree use the SFP algorithm? No, it doesn't. What it does is it uses a graph computation based on those bids, but there is no maintained database. That's one of the problems with spanning tree. If it used the SPF algorithm, it would rely on that and be able to create a database. But no, it doesn't use the SPF. It doesn't use Dijkstra's algorithm at all. Maybe loosely based on it. It depends on what Radia Perlman and that bunch did. But inside the context of our discussions, no. So do show spanning tree for VLAN 1. We are now the root. So now that we're the root, what we're going to find is that I'm going to have computational values to get to that particular device. So I'm going to follow this track right here. I'm going to follow Cat3 to Cat1 to Cat4. So that's going to be this link right here. So we'll start from here. We'll start from Cat1. So let's go over to, Cat4. And take a look at the values that we see here. So exit. So I'm going to say show spanning tree for VLAN 1 interface FAO 19 detail. Now, just like we said here, notice we have a designated path cost of 0. We take that path cost and we're going to add it to our own cost locally, and that's going to give us the value here of 2. So 0 plus 2 equals 2. Now let's cut over to Cat1. Show CDP neighbors. Let's see, to get to Cat4, it's going to be 20. I thought I disabled that. No. Error, disable, recovery. That's going to force me to do the whole thing. Cause, let me remove this, guys, I'm sorry. BPDU guard. Do show run, pipe include, error disable. All right, that's now gone. Let me double check this from R1. Show run interface G01, and it's not there. I don't know why it was constantly running. All right, but we wanted to look at this from Cat1. So show spanning tree, and if I remember correctly, it was what? It'll be 19. Show spanning tree VLAN 1 interface FAO 19 detail. Now when we look at this, let's see what we have now. Let's take a look at, we have a designated path cost of 0, and we're going to be adding to it our cost of 19. So when we look at the drawing up here, we've got 19 for this link. It's coming up. So R1 knows that its cost to reach Cat4 is going to be this idea of 19. So now what we want to do is we want to move down here and take a look at what Cat3 sees. So when we get to Cat3, what we do is we're going to look at, I think 19, show CDP neighbor. Actually no, do show spanning tree for VLAN 1. And we're going to have 21. So do show spanning tree VLAN 1 interface FAO 21 detail. Okay, now what we're doing now is we have the designated path. So the designated path cost that we're seeing here is the 19 that Cat1 sees to reach Cat4. So we're advertising that down with a designated cost of 19. So that's the information that we have and what it's going to cost us to reach this device. That's going to arrive, and then what is going to happen is Cat3 is going to look at this interface and it's going to add its own cost to it. So that cost is going to be 19. So what's going to end up happening here is my own path cost would be 19. So I would actually take 19 and 19 and I would create 38. And if I had another device down here, say Cat6, that's what I would report as my designated cost as 38. And then Cat6 in this scenario would take its cost, which would be 19, and add it to that, and then it would pass it on forward. And that would be how we register and we send everything down. The other thing that we want to look at here is notice that we have multiple links between our devices. So between Cat 1 and Cat 4, I have 2 links. So let's take a look at what those are. So on Cat 1, show spanning tree VLAN 1. Okay, that doesn't help me anything there. I need to know what I'm connected to. Show CDP neighbors to just discover my interconnections. So I know I'm connected to 4 on 19 and 20. So now what I want to do is I'm going to come back up here and execute the other command because I want to see exactly what's going on. So I'm going to say show spanning tree VLAN 1. And on 19 and 20, notice this is a root port. This is an alternate port. Notice this is blocking. Now an alternate port, we talked about designated ports. Designated ports lead away from the root bridge. Root ports lead towards the root bridge. Alternate ports are ports that we can use to replace the root port if we were to lose connectivity to it. So now we see 19 and 20, but notice what we did is we picked 19 as the root port. Now what I want to do is I want to find out why. So on Cat 1, when I look at this, I'm going to use that same command again. I'm going to do show spanning tree VLAN 1 interface FAO 19, and I'm going to compare that using the detail command to the output of 20. So now looking at this, we have both of the ports that we have. We have port 21 and port 22, which is FAO 19 and 20. Let me grab my eraser and get rid of that garbage. All right, so now recognizing this, let's look at how we made our determination. So first of all, we look at cost. Cost 19, cost 19. So cost of 19, cost of 19. So the question here is why, if these are the same, now I need to have some kind of tiebreaker. Now, the rationale behind this is I need to take a look at priority now. So my port priority is 128. My port priority here is 128. So what's going to happen is since I have a port priority of 128 on both of these, what's going to end up happening is the tiebreaker ends up being the lower port number. Now, here's what we're going to look at. All right, right now, we know R4 is the root bridge. Now, if I want to be able to manipulate this process to where I want to pick, say, 20 over 19, I have 2 ways of doing it, and I have to do it from 2 different locations. If I want to make a change on Cat 1 itself to be able to manipulate this decision, all I've got to do is go to the interface in question and give it a lower cost. That's the main point here. Cost is a local decision. So let's do that. Let's cut over to Cat 1. And what I'm going to do is I'm going to go to interface 20 and I'm going to give it a lower cost. So I'm going to come in here, config T, interface, FAO 20, and I'm going to say spanning tree, cost, and I'm going to assign it a cost of 1. Then what I'm going to do is I'm going to do show spanning tree, VLAN 1, and let's see what happened on those links, if anything. Well, let's see. We've got 20 is now listening. Notice 21 is now forwarding. 20 says it's the, 19 is now the alternate since 19 and 20. So 19 is now the alternate, 20 is now the root. It's going through its listening and learning process. Let's see if it ultimately converges. Okay, 19 is now blocking and 20 is now forwarding. Exactly, the bridge IDs are the same, but Pablo, the reason I didn't mention the bridge ID is because both of these links lead to the same bridges, so the bridge ID is going to be the same for this end of the link, yes. So all I did is I went to 20 and I made it a cost of 1. So now what ends up happening is 20 is now the root bridge, or the root port. Now let me pick another color. 20 is now the root port. This one is now what we're referring to as an alternate, and it's also blocking. Now, cost, I can only change cost on the idea of, or on the configuration of a local device. Now, the point is if I wanted to pick or change this, what I'm going to do is I'm going to remove the cost value that we configured. But before we do that, let's take a look at what happened here. So again, I want to do the output of the show 19 detail and the show 20 detail. And I will grab my eraser and we'll go back through this. So when we look at the output of these two values, what we see here is immediately we know we're going to the same switch. So the bridge ID is not going to be a problem. We're determining the links between two devices themselves. So since the bridge ID matches for both of these, since the actual root bridge itself or the bridge ID matches, that's not going to be an issue. Then the first thing we do is we look at cost. This one has a cost, let me see here, sorry. This one has a cost of 19, that's 21. This one has a cost of 1. Lower cost is automatically going to be the value. But what I want to do is I want to eliminate that command right now. So I'm going to come in here, config T, I'm going to say interface FAO 22, and I'm going to say no, spanning tree, cost 1. Do show run interface FAO 22. And then we'll repeat the command just to see what the status is, see if it's shifted. Do show spanning tree for VLAN 1. What we're going to see here is 19 and 20. They haven't reverted back over yet. See what happens. It still hasn't reverted. Do show run interface FAO 19. Oh, it's still there. Now it's gone. So let's execute the do show spanning tree for VLAN 1. Yes, if I change the cost on the individual link in the trunk or on the trunk, yes, it changes the values for every VLAN calculation. Now let's take a look at this. Now notice here, at 19 it's returning back to its normal state. So the question was, is if I do spanning tree cost and just assign it here, I'm changing it for the value for everything. But I can actually come in here and say spanning tree VLAN 10 and I can assign a cost specific to the VLAN. Does that help you, Jeffrey? So if I only wanted to affect VLAN 10 traffic, I'd just specify the VLAN. I just used the spanning tree and did all VLANs. Now, looking at this, I could do VLAN 1 obviously. So the other output here was this port priority. But the thing you need to understand is that if I need to affect this decision as to which one of these links is going to be used, and I can touch the device where I want to make the decision on, I need to be able to use cost. However, if I'm not allowed to make a configuration change on Cat 1, I have to make a configuration on Cat 4, and that means I'm going to use the port priority. The port priority command. So if I wanted to manipulate this election, what I'm going to do is I'm going to go to Cat 4. I'm going to pick the interface that I want to become the device or the root port on Cat 1, config T. So the one connecting to the port that I want, that's going to be interface FAO 20. And I'm going to say spanning tree. And just to illustrate the point, what we're going to do is we're going to come in here and we're going to use the VLAN 1. And what I'm going to do is I'm going to use port priority, and lower is better. But it needs to be in increments of 16. So what we'll do is I will say 0. Actually, no, 0 will stand out very clearly. And then what we're going to find is when I go back up to Cat 1, we should have reconverged. So show span, we should be reconverging at the very least. Notice right now 20 is now the root port, just like we had it before, and 19 is now alternate and blocking. Now the reason that this happened was because of the simple fact that we've changed the computation. So here's the deal. Let's take a look at this. So exit. Let's take a look at the output of 19 and the output of 20. Okay, first of all, let's look at it. We said that they're going to the same switch, so bid's going to be the primary reason. Then we look at cost. Cost 19, matches. Now notice here we have our port priority and port priority for both ends of our link, and notice that this is going to be 128 and 128.21 and 128.22. Now what we always want to look at in this scenario is going to be designated values. Designated values is information that we learned from our neighbors. So what we're going to do is we're going to look at this output right here, and we're going to say the designated port ID for this link is 128.21. Designated path cost is 0. That's fine. It's not an issue. And then down here what we're going to see is designated port ID is 0 and 22. 0 is lower than 128. Therefore, port 22 or Fast Ethernet FAO20 got picked to be the device that's going to be forwarding, and it's going to be our root port forwarder. All right, so William's saying, and since both ports are the same, you are using it to break the tie. Exactly. The port priority configuration is being used to break the tie. If the port priority remains the same, it'll be the lowest port number that we see in the compilation. Now later on, when we start talking about port channels, you're going to find out that these numbers will get a little bit large and they'll actually look different, but the main goal here is the same. Lower is better. So looking at this, all I want to do is I want to illustrate two other components, and what we'll do is get you guys into labs, and we'll lab until lunch and then cut away for lunch. So the main thing that we're going to look at right here is that we've talked about BPDU guard, I talked about error disable, talked about error disable recovery, we talked about the different commands, we've talked about how to manipulate the election on our links, we've talked about the root bridge election process, which is overly simplified if you just look at it step by step. Everything relates to the bid. Almost always in the confines of layer 2, it's going to be the lower value is going to take priority, so the lower is better. If I increase the bandwidth, obviously I'm going to have a decrease or an improportionate ratio with regard to cost. So the higher the bandwidth, the lower the cost. The lower cost, the better for spanning tree. So also looking at this, we also want to dive into another component. The other component is going to be this idea of root bridge protection. So if I set my system up to where right now, let's say Cat 1 or Cat 4, I think is the root for VLAN 1, just to double check. Show spanning tree VLAN 1. What we see is I am the root bridge. Now I want to remain the root bridge. So what I do know is I have a connection to an upstream device on 19 and 20. Now irregardless of what's happening on those ports, whichever one is going to be the forwarder and whichever is going to be the alternate, what I want to do is I want to make certain that Cat 1 can never become the root bridge for VLAN 1. That's primarily all I'm trying to set up here. So what I want to do is I want to look at how I've done this. Notice my problem here is my priority is 0. So let's see if I can modify this. I want to come up here and say config T, spanning tree for VLAN 1, and I want to say my priority is going to be 4096. Now let's see if it remains the same. See if it's still a root bridge. If not, then we may have to get in and do some tweaking. But do show spanning tree VLAN 1. All right, this bridge is the root, and this is my configuration. All my ports are forwarding and designated, which tells me that I'm the root bridge. So now what I want to do is I'm going to go to these configurations. I'm going to say interface range FA019 220. And what am I going to do? I'm going to tell it that I want to use spanning tree, but what I'm going to come in here and do is I'm going to say guard, and I'm going to specify root. Now when we've talked about uplink fast, backbone fast, port fast. Other things that we need to do is we also have the capability of having loop guard, which is designed to look at BPDUs that are being sent and ensure that we have bidirectional communication, but we're not receiving the same information back that we've sent. That's enabled right here for loop guard configuration. Again, you'll have a lab on that. And what I want to do is I want to enable root. Root is I want to block superior BPDUs coming into my system. So what we've got is the first of all, here we have root guard enabled, But the problem is I enabled it for everything. So I've got spanning tree root guard, and what we're going to find here is I have multiple VLANs. So what's happened here is root guard is actually blocking VLAN 10. Because according to the configuration for VLAN 10, another device is going to be the root bridge. So when we start looking at this, let's see exactly what happens. So we'll come up here and say exit, show spanning tree, and I'm going to specify a VLAN. I'm just going to hit enter and we look at all the VLANs. So right now, this is for VLAN 1. Everything's copacetic. All my statuses are up. Everything seems to be operational. This is the root bridge. On VLAN 10, we're the root bridge. And notice right here on 19 and 20, we're blocking, and we are in what's referred to as the root inconsistent state. Root inconsistent state tells me I'm receiving a superior BPDU on these links for that VLAN. So what I want to do is if I stop that process, so if I come over here for VLAN 10 and say config T, and I say spanning tree, VLAN 10, and I say my port priority is going to be 0 if that's permissible. What we'll find here is that this process will actually correct itself, provided I need to look at 10. So 3277, yeah, I should be able to assume the role with no problems. So now when I come up and I do my show spanning tree VLAN, or just show spanning tree, what we see here is notice I just had to wait. Root guard was unblocking. So I didn't have to use an error disable process. I didn't have to go in and remove anything manually. All I had to do was stop the situation where I'm receiving the superior BPDU, and we can see that the process is actually coming up. So just to streamline this, I'll just say VLAN 10, and we should see everything go through the listening, now the learning, and then ultimately we'll move to the forwarding state. And we're forwarding, and everything's good to go, and we are still, like we said, we wanted to be the root bridge. So that's the one solution. The only other solution is the solution that I detest and hate, and that's going to be BPDU filter. BPDU filter is dangerous. I've never seen a use for it in a live environment. I don't even know why it exists other than to watch people shoot themselves in the foot with it. So the main objective here is that I go in and I can configure BPDU filter in the same way that I can configure BPDU guard. BPDU guard can be in the global command in unison with my portfast configuration, or it could be installed on the interface level. If it's enabled globally and I want to disable it, I just use the no form of the command with regard to both BPDU guard and BPDU filter. Now the situation is this. Filter does exactly that. It filters BPDUs. So if I enter the command to do BPDU filtering in the global configuration, what's going to happen is every interface that's in portfast is only going to send a few, maybe as many as 7 BPDUs for the purposes of fabric discovery, layer 2 topology discovery. Now the situation is that that's okay, that's fine. But if I do it under the interface, what's going to end up happening is that I'm not going to send any BPDUs for the purposes of discovery. So under the interface, it's a hardcore configuration that's only going to work for the base configuration. We'll send no BPDUs. But if I do it globally, since I'm applying it to all my interfaces, it's almost like Cisco's decided that we want to send a few discovery BPDUs just in case, and then we're going to start filtering. Now, the reason I'm pointing this out is that Cisco may tell you in the exam that you need to do something with regard to BPDUs, and they may imply that you either need to send a few or you need to never send any BPDUs. Now, the case in point here is that's basically they're hinting at where you're going to be doing your base configurations. All right, so what we're going to do is, with all of that wrapped up, I want to put you guys back into the labs. The labs that I want you guys to do, give me one moment, are going to be labs 8 to labs 14 in the workbook that I gave you. If you do labs 8 through 14, you should be able to be done within 20 minutes, tops, even if there's issues. If you run into issues or problems, please communicate them to me so that I can get the working draft or the rough cut actually edited before too late. That way I can just submit that to editing and make certain that there's no replication of issues or errors. But the main thing here is like I said, you should be able to accomplish this lab in 20 minutes. I'm going to give you 30. And then what we'll do is by that time we should be close to having a conversation about port channels or ether channels, and then what we'll do is we'll break for lunch. All right? So I'll see you guys back here in 30. And I got a question here. Pablo's got, why am I using ISL in the lab when ISL is not in the labs while ISL is not in the actual CCIE lab? Because what ends up happening here is the fact that our devices are going to negotiate ISL from the very, very beginning, whether I want them to or not, because I haven't changed any of the baseline configurations. Also, the other point is that simply because it's not in the lab, I don't want to ignore it. I mean, I have students every day that are asking questions about things, so I just wanted to make certain that we had it included. And since it's going to negotiate it initially based on the type of devices that we have, I felt that it was necessary to cover it. And I also made decisions like that regarding other features or capabilities in other sections. Later on they do, but the thing is our labs are running 12 on the catalysts, and ISL is still an option. So if a student went in and did desirable and it negotiated on its own, what I wanted to make certain is they understood what ISL is. Got to bear in mind, we got guys that are starting the track from the very, very beginning. And I as a student, if something happens automatically on the device that I'm working on, I want to make certain that it exists, that I understand why and what it is. So that's the reason. So I included it in the books by way of abstract or by learning abstraction. All right? Great question, though. Good observation. In fact, it's already been asked twice on the forum. Now, when we get the racks, when I get the switches, if I choose to go to 15 code on the catalyst, which I'm looking at doing, we will be removing it. Therefore, it won't be and I'll remove it simply because it's not going to be a normal negotiation process. All right. All right. You're not bothered by ISL. Carry on with your life. You don't want to sell death sticks.